Plans say that this distance here between the blade and the edge of the carrier of the blade guide is 0.6 or 6 millimeters, and I just wanted to check that that's true, and it is. Although I cut this angle slightly differently here, I didn't change these dimensions here. And then when you attach your block where the guide blocks will go to the carrier, the blade should be in the middle. Can't actually see that in the picture, but it is in the middle. You'll have to trust me. There. And I'm going to do a couple of things slightly differently based upon later builds, the 14 and the 20 inch or whatever the bandsaw number n, where n is a very large integer, actually ends up at. I've put a channel here. I didn't want to countersink these two in a small piece of wood. I've carefully drilled out, of course, the pilot hole in here and a clearance hole in here for these two screws. And instead of machining space for a T-nut on the back and putting the actual blocks through into a T-nut, per later videos I'm going to tap this Sapele hardwood here and put the screws, the knockdown screws, the IKEA screws if you like, straight into this block here rather than a T-nut at the back. I'm just doing some experiments on hardness for the guide blocks, the ones that actually rub up against the blade. And of course, as they're rubbing up against the blade, what you really want to know is their resistance to abrasion. But hardness is quite interesting. Here's some cheap, rubbishy, quick-grown pine from the local DIY shed. And this is an auto punch. You could, if you're starting a hole in a piece of metal, put a punch on and whack the punch, but this thing is a spring-loaded punch. So it's set fairly hard and pushes pretty deeply into this quick-grown pine. This is what I made the shaft mount blocks from, and it's actually not all that hard. I think it might be oak looking at the grain of it. This is a piece of what I've been assuming is Sapele. It comes from an old bookcase I took apart. And this is what I've bought as Sapele, labelled thusly. And it is harder than this. So I think that might actually have been a mahogany cabinet that I took apart. So Sapele is the hardest I've got available to me. I'm working on the upper blade guide. I've made it, as with a couple of other parts, oversized just until I'm happy with the dimensions. I'll trim this here and I'll trim this here. I've got the guide blocks themselves, I've got the block mount here, and I've got the carriage here for different blades. And now I'm working on the thrust arrangement. If you've seen the 16-inch bandsaw plans, you'll know that this is actually more complicated because it presents the bearing to the blade in the seemingly more elegant orientation this way round. But apparently that's actually noisy, and that's the reason why most manufacturers don't mount the bearing that way round and instead present the outer race this way to the back of the blade. And that seems to work better. The inelegant solution is the right one. And of course it's a lot simpler because all I have to do is tap into here and then I can wind this bearing in and out. And then a slit around here will mean that when I tighten, a slit that way will mean when I tighten up on this carriage here, I'll also tighten up this block onto this thread. So I had to find some packing for the inside of the bearing here, and I found that the body of a felt pen was 9.5 millimeter outside diameter, which is what this bearing is. And the inside diameter of that pen body is almost the bolt. A little bit of copper tape around that should pack out the remaining insides. Or you could do what Matthias did, which is find some skinny washers and drop them into the inner race around that bolt, and then put some normal bigger washers either side of that bolt. Next is the trunnion support beam. It fits to the lower horizontal of the C-frame over here. You have to cut a notch out of here to clear the wheel, and it cantilevers quite a long way over here. The front trunnion has to clear the wheel and it has to leave room to manoeuvre the blade in and out. One thing that's going to be quite important when you fix the trunnion cradles to the end of the trunnion support beam is to know exactly where the line of the blade is, so I've marked that on here. Apologies for the quality of the light. I shoot by available light, and here in December in London there isn't much light available. Well, this trunnion support beam is one of the more complicated cuts. You've got your 4 mounting bolts here, which can be a challenge to drill. You've got a chamfer here, which allows the table to actually tilt down here like that. The trunnions themselves need a bit of clearance, so you've got these relief slots at either end here. You've got a wheel cut out here, and then the final one I've got to make is a cutout here to get the blade guide in. That's the last cutout done, and it's now mounted onto the C-frame. All these cutouts, chamfers, reliefs were done on the table saw, and now I'm just going to borrow the upper wheel mount block to verify the geometry that's needed here and confirm that we need a bit more thickness on that side there, but otherwise it's roughly the same.
For the lower wheel mount, I'm trying a different experiment. Instead of a bearing, rim on or face on, I've got a ceramic disc. John Hayes, for example, did a sawmill bandsaw, and he used ceramics in the guide. So I thought it was worth an experiment, and some manufacturers indeed use ceramics in the guide. Now I'm not sure if they're referring to the actual blocks themselves or the thrust mechanism here, but I'm trying it. Now I couldn't find a really good ceramic disc. This is an insert from a 1/4 turn ceramic tap, so I have to try and pick a orientation where the blade, unlike that test, where the blade is actually across the full surface of the disc. But I shall carry on looking to see if there's some other ceramic disc source I could press into action.
I've put the blade guard here. I've put a temporary blade guard over here. This one, it's suggested, is made in metal because there isn't much room. This one apparently is in wood, though I'm not quite sure why. And I've attached a temporary table, and that's an important landmark moment because it means I can now use the bandsaw to cut out one of its own pieces, and that piece is down here. This is a sort of a leg supplement that also acts as part of the dust enclosure, and there's a corresponding leg supplement to go here, but it has a curve cut out of it, and I assume that's to help you change the blades. And that curve would be pretty difficult with any other technique, so I'm going to cut it out on the bandsaw, and it's going to be a bit wobbly, I suspect, as I haven't had much practice at using a bandsaw. And then when that's done, the other piece that's really only possible on the bandsaw is the trunnions for the proper table. The tilting table tilts on trunnions, curved segments of circles that go underneath it, and they're going to have to be cut out on here. Well, hey, not bad. There's one thing that worries me about this design. These square guide blocks with their single axis of attachment. Could they not catch, especially as the lower one fills up with sawdust and the blade suddenly try to turn them round and jam up? I might have to think a bit more about that. With this right hand leg extension slash enclosure now fitted, the stability is much improved. You'll note that I haven't got the hooks here that the plans have, if you've looked at the plans. I'm not going to fit the panel that comes down here onto hooks. I'm going to use magnets. I have forgotten to shorten the shaft back to the Jubilee clip here, which is going to be awkward now I've put these sides on. And that isn't something I forgot when I did the top one, because now the enclosure is made for the top. This is pretty much as per the plans. I kept this piece of aluminium I used in the temporary guard as the main guard. It seemed quite a bit easier than the wooden one of the plans. The only other significant modification is here in these pegs that hold it on to the frame. I've spaced them out by 6mm to bring the whole thing forward by 6mm to clear this shaft end here in Jubilee clip, because on the plans the shaft ends with a washer and a screw, and that extra space isn't needed. And I haven't got quite enough space. It does tend to scrape a bit as it goes on, but as the shaft isn't rotating, that's okay. I'll see how this warps. I might move this out even more, but I think it's all right.